Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to understand, path manipulation in EIGRP. But before that, you will understand configuration, like basic configuration of EIGRP. If anyone don't know how to configure EIGRP, I will show you some troubleshooting command while configuring EIGRP and some advanced command as well. Then as you can see in this topology, I have one ISP as well, internet service provider. Here I am running one IP address 8.8.8. So we will configure one default route towards here and one default route towards here, right? We will perform NATing on R1 also and R2 also if required. Otherwise, we will configure one default route and R1 will be able to ping 8.8.8. Then we will redistribute that default route in EIGRP so that R3, R4 and R5 will also get default route towards ISP or towards R1 and R2, because R1 and R2 is my edge router here. We will configure EIGRP stub here also. As you know, EIGRP stub configuration is required. And our main motive of this video is path manipulation. Like you can see on router number 1, I have configured some loopback, and on router number 2 also I have configured some loopback. On router 5 also you can see we have some loopback. So with the help of summarization, we will understand the advanced path manipulation in EIGRP. Like if I will talk about the by default behavior. So let's say 1.1.1.0, these all network. How router 5 will get these all network? One via router number 3, right? One via router number 4 with same metric. But and maybe R5 is performing what load balancing, because from both sides it calculating equal metric. So what I want, that R5 should install only one path via R3 or via R4, right? In case of EIGRP, means whenever R5 will receive any traffic for, let's say, 1.1.1.1, let's say for this destination, so R5 will always forward traffic to R3, not to R4. But by default it have installed both path in their topology table and routing table. I will show you that also, right? So we will understand this type of path manipulation, or we can say like 5.5.5.1.1.0 network. This is 1.1.0 to 1.1.5, and here 5.1.1.0 to 5.1.5.0, right? We have some networks over here on R5 also. And R1 will get these network information via two side, via R4 also and via R3 also, maybe with equal metric. So we will verify if R2 have received both path with equal metric, so it will perform load balancing. But let's say I don't want to perform load balancing, I want to use only this link, right? And sometime my requirement can be R2 should be receive one summary route for these all prefixes via router number 3, and it should receive all individual prefixes via router number 4. So this can be my requirement also. That means I want to use this path as a backup path, or you can say secondary path, and this should be my primary path. So we will configure this type of scenario in this video. But before discussing the advanced path manipulation or summarization, first of all, let me configure EIGRP in this topology, guys. I have just configured IP address on all routers, and on internet router also I have created one loopback, and I have configured one IP address on this interface, one IP address on this interface. If I will tell about the IP address of this interface, so it is 100.1.1.2 and 100.1.1.1. I have configured company side router. Okay, this is my, let's say, company router. So you are going to learn, guys, lots of verification, troubleshooting and configuration in this video of EIGRP. These concepts can help you to understand advanced concept of BGP, advanced concept of other protocols like OSPF, BGP and ISIS. So to understand the advanced concepts of those protocol, you need to understand the basic path manipulation in case of EIGRP or in case of OSPF. Okay, so after watching this video, right, you will understand all possibility path manipulation in EIGRP. Okay, guys, so without wasting our time, let's begin. First of all, I want to show you the IP configuration of routers. So by the way, IP is in front of you in topology also, and if you want to see on router, so see, so IP interface brief, exclude, unassign. Here I am running this loopback, and this is the physical interface IP address. So on fast Ethernet 0/0 you can see 100.1.1.1. On fast Ethernet 1/0 you can see 13.1.1.1. And if you want to check the connectivity that I am able to ping ISP public IP address from here or not, so ping my IP address is 100.1.1.1 and ISP side IP is 100.1.1.2. So you can see, sorry, I have write ping twice. So I can ping this IP address. Okay. After that, if you want to ping 13.1.1. Let me ping again. And you can see not 10, it's 100, guys. I'm writing wrong again and again. It's not 10, it's 100. 100.1.1.2. So you can see I'm able to ping ISP1 public IP address. After that, on physical interface F1/0 which is connected with R3, I'm running 13 networks. 13.1.1.1 is the IP address of R1 interface. And if you want to ping 13.1.1.3, which is the IP address of R3 F1/0, this interface of R3, you can see I am able to ping. That means all devices are reachable with each other, means all connected devices are reachable with each other. So IP interface brief exclude by running this command, and we have some loopback 1.1.1, 1.1.2.1, 1.1.3.1. So on each loopbacks you can see different network ID. Okay. On router number 2 also you can see, so IP interface brief exclude unassigned. I have configured the IP address. These are the IP address of physical interface F0/0, which is connected to ISP. IP address is 101.1.1.1. And if you want to check connectivity, you can ping 101.1.2. This is the IP address of ISP interface. So you can see I'm able to ping. Right, on physical interface F1/0, which is connected with R4, I am running this IP address. And on interface F2/0, which is connected to R3, I am running this IP address. After that, we have some loopback over here. Like this, I have configured the IP address on all routers, guys, but I have not configured any routing protocol. So IP protocol over here you can see. Right, so first of all I am going to configure EIGRP protocol over here. Before that, as you know, on edge router one default route is required, because now I cannot ping 8.8.8 from R1. So let me configure one default route over here. IP route, actually I am going to configure this topology like real time. In real time, how we will configure EIGRP. So at the last, you will understand, after learning the path manipulation, all the possibility path between source and destination, you will understand in real time how we need to configure EIGRP protocol in the network. Okay. So IP route 0.0.0, 0.0.0, and next hop IP address exit interface first of all is F0/0, and next hop IP address is 100.1.1.2. In real time, we configure default route and static route with the help of both exit interface as well as next hop IP address. Done. In the same way, let me define one default route on router number 2 also. Config T IP route 0.0.0, 0.0.0, and F0/0 101.1.1.2. Done. Now you can verify from router 1 and from router number 2 you can ping 8.8.8. But definitely your LAN user or other router, means R3, these router cannot ping until we will not configure NAT over here. Right. So now you can see R1 is able to ping 8.8.8, but I cannot ping 8.8.8 from LAN interface, means from if source is fast Ethernet 1/0. So if you want to make communication from to internet from LAN interface, we need to configure NAT. So let me configure, actually in real time we will configure NAT also, PAT. So let me configure PAT as well over here, then I will configure EIGRP. So to configure PAT, first of all I need to configure one access control list, access list. After that, list number is 10 and permit, let's say, any. After that, IP NAT inside source list source match from list number 10 and convert it into interface f0/0 overload. Done. Now I can ping 8.8.8 from my LAN interface as well. So ping 8.8.8 source fast ethernet 1/0. Still I am not able to ping because we need to define inside and outside interface. Until and unless you will not define interface inside and interface outside, NAT will not work. So interface f0/0, as you know, this is IP NAT outside, and exit interface f1/0 IP NAT inside, and interface f2/0, this is also inside IP NAT inside. And now if you will ping 8.8.8 and source is this one, you can see it's working. Ping is working. Now from LAN user also I can ping 8.8.8, means NAT is also working fine. If you want to configure NAT on router number 2 also, so you can configure one NAT here also. Access list number 10 permit any. After that IP NAT inside source list number 10 interface f0/0 overload, and then interface f0/0 IP NAT inside, sorry, interface f0/0, this is IP NAT outside exit, and interface f1/0 IP NAT inside, and interface f2/0 IP NAT inside. So I have configured the NAT from here also. If you want to ping 8.8.8.8 and source is your LAN interface, that is f, let's say 2/0. So you can see I am able to ping. Right now guys, I am going to configure EIGRP. So make sure on router in real time, whenever you will configure EIGRP on edge router or any routing protocol on edge router, you will not advertise your WAN interface, right? Like this interface, I will never advertise this interface in EIGRP. On router number 2 also, this is my WAN link, so we will not advertise WAN link in EIGRP or any other routing protocol. So first of all, I am going to configure EIGRP on router number 1. So let me configure. Command is very simple, as you know, router EIGRP, then ES number 10. After that say no auto summary and network. Network is 1.1.1.0, network 1.1.2.0, network 1.1.3.0, and you can define wildcard mask as well, 4.0 and let's say 5.0. So I have advertised all loopback interface. After that network 13.1.1.0 f1/0, I have enabled EIGRP on f1/0. Let me enable it on 2/0 also, that is network 14.1.1.0. So I have enabled EIGRP on all interface of router number 1. Guys, I am going to save the configuration of R1. Say right. Done. So IP protocol, you can verify I am running EIGRP and we are here by default. Let me check one thing, automatic summarization is disabled. Protocol EIGRP 10. But can anyone tell me it will advertise all individual prefixes to router to their neighbor or a summary route by default? So we will verify that also. First of all, let me configure EIGRP on router number 2, guys. Here I'm going to say router EIGRP ES number 10, no auto summary, and here I am going to use wildcard mask as well while advertising the network. 2.1.1.0 wildcard mask 0.0.255, network 2.1.2.0, 2.1.3.0 and 2.1.4.0 and 5.0. So I have advertised all loopback interface. Now I am going to advertise the physical interface. 23.1.1.0, 0.0.255 and network 24.1.1.0, 0.0.255. So here I have defined wildcard mask as well and network ID and wildcard mask. On router number 1 I have defined only network ID. Now I am going to configure EIGRP on router number 3. So let me take you to router 3 and say config t router EIGRP AS number 10, no auto summary, and network 13.1.1.0.0.0.255, network 23.1.1.0.0.0.255. Here you can see the new EIGRP new adjacency with both router R1 and R2. So I have defined network 13 and 23, and let me advertise 10.1.1.0.0.0.255 also from here. And now guys, on router number 3 I want to check routing table of EIGRP. So IP route EIGRP. So it have all these individual prefix and all these individual prefix as well, right? So router number 3 have received all loopback interface of router 1 also and router 2 also. Done. Let me configure R4. Enable config t router EIGRP as number 10, say no auto summary, and network 24.1.1.0.0.0.255 and network 10.1.1.0.0.0.255 and network 14.1.1.0.0.0.255. Done. I have enabled EIGRP on all interface of router 4 also. So IP EIGRP neighbor. Here we can verify there are 3 neighbor of router 4. Okay, in topology also you can see router 3, router 1 and router 2. There will be one more neighbor R5 when I will configure R5. Okay, so let me configure R5 now. Here config t router EIGRP as number 10, say no auto summary, and network 5.5.1.1.0. Guys, we can define wildcard mask as well and we can leave as well here, because I have disabled auto summarization and EIGRP is a classless routing protocol. 5.1.2.0, 5.1.3.0, 4.0 and 5.0. Then network 10.1.1.0, 0.0.255. Done. Okay, so IP EIGRP neighbor. So you can see there are 2 neighbor of R5 also. Now done. Okay, first of all I am going to show you the routing table of R5. So IP route EIGRP. Guys, in the routing table of router 5 you are able to see for all these individual prefixes like 10.1.1.0 there is two path. One is via 10.1.1.4 means router 4, and one is via 10.1.1.3 means router 3. Means router 3 and router 4 both are advertising this network 1.1.1.0 with same ID value and same metric. From both side metric is same. So router have installed both path in their routing table, and router 5 will perform load balancing for 1.1.1 for 1.1.1.0, 1.1.2.0 to 1.1.5.0, and for 2.1.1.0 also you can see both router 3 and router 4 both are advertising with same metric and same AD value. So router 5 have installed two path for the loopback of router 2 as well, for 2.1.1.0 to 2.1.5.0. Done. In the same way, when router 1 will receive 5 prefixes, the loopback of router 5, so IP route EIGRP all 5 prefixes, it is router 1 is receiving via two path. 14.1.1.4 means via router 4 and 13.1.1.3 means via router number 3 with same metric and same AD value. Getting my point? These network router 1 is getting via router number 3 also, and it is getting via router number 4 also, with same AD value and same metric. So it is also performing, router 1 is also performing load balancing. Now let me check for the 2.1.1.0 network, the loopback of router 2. So see, this network is also reachable via two path, means via router number 3 and via router number 4. So it is reachable via again router number 3 and router number 4, all 2.1.1.0 to 2.1.5.0 prefix. So router 1 is also performing load balancing. It have two path available, right? And in the same way, router 2 have also two path for these prefixes and for these prefixes, if you want to verify that also. So let me show you. This is the by default configuration. Router number 2 here. So IP route EIGRP. This is by default. It is performing what? Load balancing for these prefixes for 1.1.1.0 to 1.1.5.0, and for 5.1.1.0 to 5.1.5.0 also it is performing load balancing via 24.1.1.4, means router 24 means router 4, and 23.1.1.3 means router 3, right? So both router are advertising 5 networks to router number 2 also. Both are performing load balancing. Everything is working fine till here. Till here we have some problem only. Problem is router 3 or router 5 or router 4 cannot ping 8.8.8, or any LAN user, let's say 5.1.1.1 want to access internet. So now it cannot access internet because router 5 don't have any route available for 8.8.8. So IP route, if I will show you the routing table of R5, so you can see the routing table. In routing table there is no any route available for 8.8.8.0, and there is no any default route also in the routing table of router 5. There is no any default route. So if 5.1.1.1 will ping to 8.8.8, R5 will drop the traffic. So we need one default route over here. So we have already one default route on router number 1 and on router number 2. I am going to advertise or redistribute that default route in EIGRP. Simply on router number 1, I am going to run one command, router EIGRP as number 10 and redistribute. After that, if you will put question mark over here, you can see we can redistribute a static. So default route is also one kind of static route, or we can say connected. So not connected, here I am going to say static. I want to redistribute a static route here also, and on router number 2 also we can say router EIGRP as number 10 and redistribute. And here also if you will put question mark, you can see the static option. So say static. Done. Now both router R1 and R2 will start advertising default route, and R5 will learn default route via which router? So IP route. In the routing table now you can see there is one default route available, and for default route also R5 is performing what? Load balancing. It is performing load balancing. It will forward some traffic to 10.1.1.4 means to router 4, and some traffic to 10.1.1.3 to router number 3. Let me ping 8.8.8 from here first. Ping 8.8.8.8, and let's say source is 5.1.1.1. First of all, let me check, am I able to 5.1.1.1 ping or not? So yes, I am able to ping 8.8.8 from router number 5 from the LAN user. Right, my LAN user are now able to ping 8.8.8 from anywhere, right? Doesn't matter where is my LAN user connected. Let's say R3, on router number 3 we have 100 LAN user. So those LAN user can access 8.8.8, and if you will trace route 8.8.8.8 and source is 5.1.1.1.1 and say numeric, I am tracing 8.8.8 from 5.1.1.1. So see, it is forwarding traffic to 10.1.3 means to router 3, then 10.1.1.4 to router 4, 10.1.1.3, right? So router 5 can forward traffic to any one router between router 4 and router number 5, and after that next hope is when it is forwarding traffic to 10.1.1.3. Then traffic is going where? 24.1.1.2, 24.1.1.2 here, right, via router number 4. So when router 5 is forwarding traffic to router 4 is forwarding to router 2. When router 5 will forward traffic to router 3 will forward traffic to router number 1, right? Or router 3 have also two options. It can forward traffic to router 1 or router 2 also, because router 3 have also learned default route from router 1 also and from router number 2 also with same value. So router 3, if you want to check R3, so here also you can see, so IP route in the top, it is performing load balancing for default route. Yes. So okay, all routers have two paths for default route. All routers have two paths for the LAN which is running on router number 1, the LAN which is running on router number 2, and the LAN which is running on router number 3. Guys, these are loopback. You can consider these loopback as LAN. Okay. Guys, now first of all, understand one thing. See here on router number 5, so IP route EIGRP. Because of EIGRP, let's say size of this routing table is very large. See, this is the size of routing table. In real time, size of routing table will be very large. Like let's say there are thousands of prefixes in the routing table of router 5. Let's say here we have note only 5 loopback. We have 500 prefixes. So it will learn, router 5 is learning 500 prefixes, and it have two path available for 500 prefixes. Definitely routing table size of router 1 will be very large. And if you want to reduce, first task is, let's say I want to reduce the size of routing table of router 5 only, because we have lots of entry in the routing table of router 5. Let's say router 5 is hanging, or CPU utilization of router 5 is high because of routing table. So admin told you to summarize the routing table of router 5 only. Rest routers are working fine, right? So what we can do, guys, here we can perform one summarization, right? I can perform summarization on R3 and on R4, right? So R3 will have these all individual prefixes, but it will advertise one summary route for these all prefixes to router number 5. So definitely routing table of router 5 will reduced. Yes or no? What I am saying here, we can perform summarization. That will be manual summarization, right? Manually we will perform summarization on router number 1, router number 3, and on router number 5 to reduce the size routing table size of router number 5. Let me show you how. This is the first use of summarization. We can reduce the routing table size of router. Okay, so let me show you. Now you are able to see the routing table size of router 5 is very large because of this network 1.1.1.0 to 1.1.5.0, and because of 2.1.1.0 network. Okay, so what I am going to do on router number 3, first of all, tell me guys, what will be the summary address of this prefix? Summary address of this prefix will be, let me tell you. See, I have some network over here, 1.1.1.0/24, then 1.1.2.0/24, then 1.1.3.0/24, then 1.1.4.0/24, and 1.1.5.0/24. Guys, if you know the summary address, then very good. If you don't know the summary address, so let me tell you, the summary address of these all prefix will be 1.1.0.0, and prefix length, common prefix length will be 21. And as you know, subnet mask of 21 is 255.255.248.0, subnet mask of /21. So what I am saying, this is the summary address of these all prefix. In the same way, we need to calculate summary address of these all prefix, right? So as you know, summary address of these all prefix means 1.1.1.0 to 1.1.5.0 is 1.0.0/21. This is the summary address. So this summary address I will advertise from router number 3 to router number 5. Means I will advertise this summary address from fast Ethernet 0/0 of router number 3. Once I will advertise this summary address from fast Ethernet 0/0 which is connected to switch, it will stop advertising all individual prefixes. Okay. So I will advertise this summary address from here and one summary address from here, that will be, so, see, router 4 is also advertising 1.1.1.0 to 1.1.5.0. So here also we will perform one summarization for this /21. In the same way, we will perform one more summarization for this network, for these network 2.1.1.0 to 2.1.5.0. First of all, let me do this and let me show you the size of routing table of router 5 then. So on router number 3, what is command? Command is very simple, guys. Here we will run command on interface F0/0 which is connected to switch 1. IP summary address for EIGRP, S number 10, and after that we will define summary address. Okay, after that summary address, so summary address is 1.1.0.0. Here I have write 10.1. Okay, 10.1.0.0, and then subnet mask 255.255.248.0, 248.0. Done. Now guys, if you will check the routing table of R5, you can see the routing table of R5. Now these prefix, both router is advertising this prefix, router 3 as well as router 4. But now if you will check routing table, so IP route EIGRP, now you can see the size of routing table is also reduced, and only router 4 is advertising this prefix. Only router 4 is advertising this prefix. So on router number 4 also I am going to run this command, this summary command. On router number 4, let me take you to router 4, and on fast Ethernet 0/0, here also I am going to run command IP summary address for EIGRP S number 10, and then network 1.1.0.0 255.255.248.0. Done. Now if you will check routing table of router 5, see now routing table of router 5, let me maximize it and let me run so IP route EIGRP. Now you can see the entry for 10.1.1.0 to 10.1.2.0. There is only two entry. Router 3 and router 4 both are advertising summary route, not individual prefixes. Let me do same for these prefixes also, because I want to completely reduce the size, routing table size of router 5. So here I will do same thing for 2 network. IP summary route, summary address for EIGRP as number 10 and 2.1.0.0 255.255.248.0. I've advertised it, and on router number 4 also, let me say IP summary address for EIGRP 10 and 2.2.1.2.2.0.0 255.255.248.0. Done. Now if you will check the routing table of router 5, you can see so IP route EIGRP. Now see the size of routing table is, it is receiving all individual prefixes from which router? From router number 4. So I think so on router number 4 I have not run this command. Config T interface F0/0 and summary address EIGRP 10 2. Okay, so I have run this command over here also on router number 4 also. So let me do one thing, clear IP EIGRP neighbor. I have cleared the EIGRP neighbor, and now so IP EIGRP, so IP route EIGRP, P route EIGRP. So still it is receiving all these all individual prefixes from router number 4, and router 3 is advertising a summary route. So let me check. I think I have configured something wrong on router number 4. EIGRP IP summary address for EIGRP 10 2.1 dot, it should be 2.1 dot. So let me say no over here, no, and then IP summary address for EIGRP is number 10 and 2.1.0.0 255.255.248.0. I was advertising 2.2.0.0, but there is no route available inside the routing table of router 4 for 2.2. So whenever you are performing summarization, make sure that summary of or all individual prefixes should be there inside the routing table of router 4, then only it can perform summarization. Okay, and now if you will check the routing table of router 5, so IP route EIGRP, you can see the size of routing table is very small, and there is only two default route, sorry, not default route, summary route available, right? One default route is there via both router, and one summary route is also there. And if I will ping 10.1.1.1 and source is 5.1.1.1, not 1.10.1.1.1, it will work. Ping will work. I have ping 11.1.1.1, so let me correct it, not 11.1. So see, ping is working. So it will perform load balancing, right? Because it have summary route from both sides. But I want, let's say my requirement is now R5 is performing load balancing for 1.1.1.0 to 1.1.5.0. But what I want, that router 5 should forward traffic to this network, in this network via router number 3. So simply I will remove the summary route command from router number 3, and router 3 will start advertising all individual prefixes. So when router 5 will receive all individual prefixes, let me make you understand with example, guys. Let me remove the command from here directly. This command, no, this command, not this command. No, IP. And how you will verify the summarization? By running command do so IP protocol. By running this command, we can verify the summarization. Like here you can see we have performed summarization on fast Ethernet 0/0 only for this network, only for this, right? 2.1.0.0. And now if you will check the routing table of R5, so IP route EIGRP, so it is receiving all these individual prefixes via which router? Via router number 3. These all prefixes via router number 3, and one summary route via router number 4. So until and unless R3 will be active, it will forward traffic to by using these route. Let's say someone is pinging 1.1.1.1. So here we have two entry actually in the routing table. One is this one, it will match in this entry also, and it is matching in this entry also. But here we have how many bits match? 21 bits only. Here how many bits we have matched? 24. And router maintain longest prefix match, so it will use this entry. It will forward traffic to 10.1.1.3. okay. If you want to trace route 1.1.1.1, and source is 5.1.1.1.1, set 1.1, and so numeric, you can see traffic is going to router number 3, then to router number 1, router 3 to router 1, router 3 to router 1, router 3 to router number 1. But if router 1 will goes down, let me down the router 1, say shut down to F0/0 of router number 1. And now if you will trace route, now you can see your traffic will go via router number 4. So what is this? This is primary and secondary. Until and unless router 3 is active, it will forward traffic to router 3. Otherwise it will forward traffic to router 4. It is forwarding now traffic to router 4, 10.1.1.4 and then 14.1.1.1. Again, when router 3 will come up, let me run no such command. It will start forwarding traffic to router number 3. It will start forwarding traffic to router number 3. You can see 10.1.1.3 then router 1. Okay, so this is path manipulation, guys. And now here actually I want to advertise summary route. So again I am going to run that command on f0/0 IP summary address for EIGRP 10, and summary address is 1.1.1.0.0 and 255.255.248.0. Done. So router 5 will have right two summary route, and it will perform load balancing. Now let me take you to router number 1. On router number 1, guys, see, so IP route EIGRP, all 5 prefixes 5.1.1.0 to 5.1.5.0, it is performing load balancing. But here also, let's say I want to forward traffic in 5.1.1.0 to 5.1.2.0 via router number, let's say 3. Via router number 3, I want to send all traffic in this network. What I am saying, that whenever these user from this network want to communicate to user in this network, R1 should forward traffic to R3 only. Right now it is performing load balancing, and if R3 is not available, or let's say this path is not available, not working fine, then R1 should forward traffic to R4. So here also what we can do, I want to use this path, so I can advertise one summary route from here. So router 1 will learn one summary route. It will stop advertising individual prefixes from this interface. It will advertise the summary route. Guys, EIGRP is very flexible routing protocol in case of summarization. We have lots of options for summarization in EIGRP, right? And see what I can do to achieve this. What I want, that whenever router 1 need to forward traffic in this network, it will forward via router number 3 if R3 is available. If R3 is not available, then it should forward via router number 4. So here we are going to perform path manipulation with the help of summarization. From this interface, we will advertise one summary route of these all prefixes. Let me do this. Let me take you to router number 4, and here on which interface, on f2/0, which is connected to router 1, f2/0, I'm going to say IP summary address for EIGRPS number 10 is 5.1.0.0 255.255.248.0. This is the summary address. Let me do it. Done. Once I have run this command, EIGRP neighborship will resynchronize, and then here on router number 1 you can run command again, so IP protocol, so IP route EIGRP, and you can see all 50 prefixes. It is receiving one summary route only via router number 4, and it is forwarding all traffic, it is receiving all individual prefixes via router number 3. So if I will trace route 5.1.1.1 and source is 1.1.1.1, you can see it will forward traffic to router 3. Control C. It is forwarding traffic to 13.1.1.3. Always it will forward traffic, either you will ping to 5.1.1.1 or 5.1.5.1. Router 1 will forward traffic to router number 3 if router 3 is available, and if router 3 is not available, interface f1/0 says shutdown. If I have done this interface, do trace route. Let me trace route in privilege mode. Trace route 5.1.1.1 and source is 1.1.1.1. it will forward traffic to router 4 now, because router 3 is not available this time. And we can manipulate with metric as well while summarization. See, it is forwarding traffic to 14.1.1.4, and again when R3 will come up, interface F1/0, say no shutdown, so and trace route numeric. It is forwarding traffic to 14, now it will forward traffic to 13. See, 13.1.1.3, right? So this is also one way to path manipulation, and both are same, right? We have discussed same things twice. Now we are going to understand another things, guys. See, router 1 is receiving 2.1.1.0/24.2 2.1.5.0 via both routers. So IP route EIGRP, these all prefixes via both router. Now my requirement is different. Now my requirement is, let's say, for the upper three prefixes, means for these three prefixes, router 1 should learn these three prefixes via router number 3, and these two prefixes via router number 4. Means what I want, that whenever router 1 need to forward traffic in these three network, in upper three network, it should forward traffic to router number 3, and whenever router 1 need to forward traffic in these two lower network, router 1 should forward traffic to router 4. So I want to utilize both link, this link as well as this link, but on the basis of network, right? So for upper 3 network, I want to use this link. For lower 2 network, I want to use this link, right? Very simple. What I will do, I will calculate one summary address of these three upper network, right? Getting my point? I will calculate one summary address of these upper three prefix, and I will advertise that summary prefix from here. So router 4 will stop advertising these three individual prefixes. So router 1 will get these three individual prefixes via router number 3 only. Done. And for these two lower prefix, I can perform summarization on this link. I will perform summarization on this interface. So this interface will advertise one summary route of these two network. So it will not advertise individual prefix. So router 1 will learn these two individual prefix via router number 4. Let me implement it. It will make you more clear. Guys, summary address of 2.1.1.0 to 2.1.2.0 and 2.1.3.0. Summary address of these three network will be 2.1.0.0 and /22, means subnet mask will be 255.255.250.2.0. This is the summary address of these three network. And if I will talk about the summary address of lower two network, summary address of 2.1.4.0 and 2.1.5.0, summary address of these two network is 2.1.4.0 4.0, and here submit mask will be also 255.255.252.0. This is the summary address. You can calculate, right? This is not our concern, how to summarize prefixes. Okay, so let me take you to router number 4 directly. Now you can see router is performing load balancing for these all prefixes, right? And any prefix you can open in details. So IP route, so IP route EIGRP, and after that EIGRP is number 10. Okay, not like this. So IP route 2.1.1.0. Like this, you can see we have two paths via router number 4 and via router number 3. From both sides, like this command, we can see the metric and distance, anything. Okay, all information we can check, or we can run command. So IP route 2.1.1.0 After that we can define the subnet mask 255.255.255.0 and EIGRP longer prefix. So you can see it have two path available with same metric, right? So this is also one troubleshooting command of EIGRP. You can run command like this. And there is one more command like in EIGRP. Before configuring it, let me tell you some command, guys. Router EIGRP is number 10, and here we can run command summary metric, and then you can define the address. Okay, summary address. After that we can manipulate metric as well. Let's say on router number 1 summary address is 1.1.1.1.0.0. after that subnet mask 255.255.248.0. let's say this is the summary address, or here we can define directly /21. after that we can manipulate with bandwidth, delay. So if you want to manipulate the metric for the summary route, you can achieve it. By default, let's say router 1 have one summary route, so IP router, not router 1, router 5 have one summary route. So IP route EIGRP, you can see the summary route, and it have this metric. So if you want to manipulate with this metric, so by running that command you can do this. Okay, now guys, on router number 1 I am going to configure my task, that how we can perform path manipulation. Here for upper 3 prefixes, router 1 should forward traffic to R3, and for lower 2 prefix it should forward traffic to router number 4. So for upper 3 prefix I am going to perform summarization on router number 4. Here I am going to define interface F2/0. on this interface IP summary address for EIGRP is number 10, and summary address of upper 3 network will be 2.1.0.0 255.255.252.0. done. Now router 1, let me show you the router 1 routing table now. So IP route, now not show IP route directly, so IP route EIGRP. Now you can see this router is not performing load balancing for these 3 network. It is performing load balancing only for these 2 prefixes, right? And all individual prefixes is learning via router number 3. Means if router 1 need to forward traffic in these 3 network, it will forward traffic to router number 3. Yes or no? Because we have one summary address of these network via router number 4. Done. It is very clear. Now for lower 2 prefixes it is performing load balancing, but as I told you that for lower 2 prefixes router 1 should forward traffic to router number 4 only, not load balancing. So I am going to perform summarization on router number 3. On router number 3, from F1/0 interface F1/0, I'm going to define one summary address, IP summary address for EIGRP as number 10, and summary address of lower 2 network is, as you know, 2.1.4.0, and subnet mask 255.255.252.0. Now if you will check the routing table of router 1, you can see, so IP route. Now this router have these all 3 individual prefixes via router number 3, and these 2 prefixes via router number router number 4, guys. So if router 1 will forward traffic in these 2 network, it will forward to 14.1.1.4, means to router 4, and whenever router 1 need to forward traffic in these 3 network, it will forward traffic to router number 3, 13.1.1.3. So these are the path manipulation, right? In EIGRP, guys, we can achieve with the help of summarization. We have some advanced path manipulation as well, but today we are not going to discuss that advanced path manipulation because the video length is very lengthy now. Let me check, the length of video is around 1 hour. So we are not going to discuss anything else in this video, but I will try to make one more video on path manipulation in EIGRP, and after that you know, route filtering is the most important part of EIGRP, so I will try to cover those things as well later. Okay, so this was just a small video for the path manipulation and to understand the concept of summarization. Guys, if you have learned something from this video, please hit on like button. If you have not subscribed this channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye guys.